Good day, everyone. You are welcome to this session of Computer Programming 1 using Java programming. Let's quickly recap some of the highlights we did in our previous class on Java programming. And in our previous class, we look at the key concepts and the features of Java programming. We look at the process on how we set our Java integrated development environment or our Java environment from the machine. And we also look at the practical aspect of Java by writing our first Java programming. I remain Mr. Bamanga Mahmoud Ahmad, and in today's class, we are going to look at the fundamentals concept of name and things. That is, how are we going to name our variables and identifiers using Java programming? Also, we are going to learn the rules, convention governing these namings and things, looking at the identifiers, the variables, and the classes in general. We are also going to look at the different data types we have in Java programming, and then how these data types work. This is what we are going to look at in today's session, so that at the end of this class, our viewers or our students out there will be able to define and explain the concept of names and things in Java programming. They will also be able to create a valid and meaningful identifiers, variables, and classes and class names according to the Java rules or Java syntax. Also, we are going to apply appropriate data types for different types of data, and then we see how those data or how these data types applies on a certain data works. Follow me in this class and see how this thing works. So, the introduction now. Names are the building blocks of any programming languages, and Java programming language can never be left behind. Therefore, understanding this or understanding how these names and things work, how they work effectively is very, very paramount in your day-to-day programming activities. Our Java programming language cannot work without these variables. They cannot work without these identifiers. So in this class today, we are going to guide you through the essential concept of these names and things, data types, operators, and then the I/O in Java, that is input, output in Java, so that by the end of this class, our students out there will be able to come up with something like they can be able to identify this data type, they can be able to apply the data type whenever the data type is needed to be used, and they can be able to apply all these operators in their day-to-day programming activities. Now, the names or naming and things in Java. In programming generally, names are used to refer to many different names or to many different sort of things. Like example, my name is Bamanga. For instance, my name is Bamanga. So this Bamanga now can be referred to as X. Are we together? So these are what? This is the name. This is the thing that I am now referring this X to this B. So whenever I see X, it means I'm using Bamanga. So in programming language, we always refers to our what? We always use our things or our names in order to refer to many sort of things when it comes to programming. So according to the syntax rule of Java, the most basic names are what? Are what we call identifiers. The most basic names are what we call identifiers. What are you identifying this Bamanga with? You identify it with what? With X. Are we there? This is what you identify this Bamanga with. So according to the syntax rule, you use your identifiers to identify anything you refer to as in this Java. So identifiers now can be used to what? To name a classes. Identifiers can be used to name a variables, and identifiers can be used to name a subroutine. That is, you have a tax 1, tax 2, tax 3. You can use identifiers in order to name all these things that we have mentioned. It's just for you to what? To manage the way in which you use these your identifiers. So looking at the rules governing these or naming our identifiers. One, that is the rules. Now we are talking about the rules. Sorry, this marker is not working. We are talking about the rules of naming identifiers. So one, our identifier must start with a letter. Our identifier must start with a letter. That letter can be A to what? To Z. Are we there? Our identifier must start with a letter. Two, the same number one, and also must start with a currency. And the currency here is not naira because we don't have naira in the in this currency. So we have dollar. We have dollar sign. That's it. So it can start with a letter, it can start with a dollar, or it can start with an underscore. Are we together? That is the number one rule. Whenever you are starting your identifier, it must start with a letter that's from A, B, C up to Z, or it starts with what? With a dollar sign, or it starts with an underscore. In essence, what they are saying here, if you are starting your variable, let's assume I want to give a variable, so I can say it my var, this is my variable. So this is what I am now naming this identifier with. So you see now here it starts with what? With a letter, isn't it? So it can also start with what? With a dollar sign like this. Then you now write my whatsoever here. Are we together? So also, it can also start with an underscore my var. So this is the number one rule. You need to master this. So number two, the subsequent character can be letters, can be digit, can be what? Currency, character, or underscore. Thus, if you start with a letter or anything here like this, if to say you are starting with a letter, you can start with a letter A like this, then you follow. So what we are saying, after you have number one rule says it must start with this. Number two, it's saying that the subsequent character can be a letter. That's how you, after you start maybe my var, you see the subsequent here are what? Are letters. And also they say the subsequent one can be a digit. After M or my, you can say it 1, 2, 3. Or after my, you can say it dollar. That's the currency, right? So, or after my, you can say it underscore var. So these are what? This is the second rule of what? Naming your identifier here in Java. So whenever you are naming it, you must maintain it start with a letters, currency, or underscore. Number two, it's what? The subsequent letters or the subsequent characters or the name in naming can be what? Letters, underscore, or what? It's still the repetition of this. So we need to know something in naming, in rules governing the naming of our identifier, that in naming these identifiers, our Java programming is case sensitive. What we mean by case sensitive is here, if you are saying name like this, it's not the same thing, with this. Are we together? Name here is capital letter, name here is small letter. So this is totally or entirely different. If you use this in declaring your variable or identifier, it means when you come to print and you're using this, you will get an error. Are we together? So that's what it means. So Java is case sensitive. in such a way that these and these are two different things we have in Java. So also, naming convention in Java, we say Java is a case sensitive. A case sensitive in such a way that your name are entirely or totally different with this name. That's the name you start with capital letter is different with what you start in small letters. So choose consistently when it comes to what? Choosing your identifiers. You should be what? Consistent. If you are using small letters in your naming, you should be consistent. If it's capital letters, you should be consistent. If you usually use underscore at the start, you should be also be consistent. So the case sensitivity here in Java, we have three types of case sensitive. We have three what? We have three types of case sensitive. One, we have camel case. Camel case. Are we together? That is number one. Number two, we have Pascal case. Pascal case. And number three, we have Hungarian case. Hungarian case. So if you take this number one, here what it means in Pascal case, if you are starting your variable, just maybe to say name and whatsoever, you can start my variable. You see this one is small letters, right? So your var here is capital letter. Are we together? It starts with small letters, then it will now, the next word that you are concatenating with this, it will be in caps, you concatenate it. If to say calculate the area of a cycle, you can use calculate area. You see? So this is what is a typical example of a camel, of a what? Of a camel case sensitive. So whenever you see, provide some example or too many examples in camel case, you can be able to write this and that's all. So when we talk about Pascal case, here we are talking about whenever you heard of a Pascal case, it means the initial will be capital, the next one will also be capital. Are we together? Or var, let's just leave it as var. So if it is calculate area, it means you have capital like this C, then you have C like this. This is what? Pascal case sensitive example. When we talk about Hungarian, Hungarian here, it means that you are going to what? You are going to combine your data type with the name of the identifier or a variable. Are we together? You are going to combine the data types with the name or with your identifier. For instance, say, here in Hungarian, we want to calculate area of a cycle. This area of a cycle, if assume we believe area of a cycle is an integer, we can set int calculate. This one capital letter. That's the combination of what? Combination of Pascal and data types. That's what will give you what? Hungarian case. Calculate area. Are we together? That's it. So if name, assuming name is a string, str, then you have first name. Did you get it? You see this what? This is a Pascal case. Are you together? This is the data type. So when you combine data type together with your Pascal case, it's going to give you Hungarian case sensitive. Are we following here? So that is for this one. Then we have what we have been saying variable all the time. So in Java, a variable is a container. A variable is a container that holds a value you stored in Java or in that programming, or a container or a bucket in which whatever things you are going to house on that particular items you are going to keep it, or you say safe. So whatever you want to keep in it, you can now identify it with its name, and then throw it in that very bucket or that very safe. So whenever you want to, you can use it for reference purpose. That's whenever you want to reference an object during the execution of your program, you can refer to that very variables. Are we together? So in essence, your variable provides you with a way with a way to store what? To store and manipulate information or to store and manipulate data within Java programming. Are we together? If you remember, at the beginning of this class, I give instance with Bamanga, which may refers to as X. It means this X is going to be kept inside, this Bamanga is going to be kept inside what? It's going to be kept inside X. Are we together? So it means it provides you with a way of storing and manipulating information within a particular container. Are we together? So let's look at some details of variables here in Java. We have two ways to look into this. We can look at our variables using our declaration, and we can look at our variables using initialization variable. Are we together? So we are going to look at the syntax of both the two here. Are we together? So looking at the declaration here, looking at the declaration of our variable, declaration, we are going to look at the syntax. That's the process which you can follow to achieve this very declaration in what? In your variable. One, you can set data type, then the variable name, variable name. Are we together? Then you have your semicolon, which you use to end a statement in Java. So what we are saying here, this is the syntax of declaring a variable. Are we together? So looking at this, what is our data types? Let's consistently at the beginning work with integer, since we did not treat data type. So let's assume int, we know this is an integer, int is for what? Integer. So this what? Then what is our what? Variable name. Our variable name can be age. And this follows the standard of naming our identifiers rule, if you remember, because it starts with a what? With a letter, isn't it? Or you might decide to say it underscore age. And there's no problem in that. So I prefer using like this, int age. So you have declared this variable now. So it means later in the process of your programming, you can come and what? And do the initialization. So that is why the next thing in variable now is what? Initialization. So there is a way you can initialize a variable at the same time declaring that variable. There are two different things. Here you are only declaring. The next one you can declare and then initialize at the same time. Looking at this, you can set that's initialization, right? Initialize a variable. So the syntax here, the syntax is what? Is the data types as usual. Data types, your variable name, then equality sign, and then the value it should contain, then semicolon. Are we following here? The data types, the variable name, equality sign, and then the value it should contain. Now going to top of this, our data types is int, our variable name is what? Is age. Equality sign is here, our value maybe say 18, then semicolon. Are we following this? So it means whenever you want to work with age in your programming, you can give this age to hold a data called integer. Normally, an integer is a whole number. It holds a data that deals with what? Whole numbers. So you see, most of our age are what? Are in all whole numbers because we don't work with what? With months. We work with years or years, right? So int, That means here, if you write it the proper way or in a proper syntax in Java programming, you are telling the program, please store an integer value into what? Into an age container, and that age should contain a value called 18. So, are you following this, please? So, we believe this is well understood. So, the next thing we are going to look at here is our data types. Data types. What is data types? Data types are types of data that you are going to store within your programming, in your programming language, or within the container, or within the variable or identifier. So your variable, your data types can specify the types of data that container can hold and the size it can also hold. Are we together? This can be stored within a given variable. So the data types in Java has something what we call primitive data types. And in primitive data types, we have what we call integer, double, and boolean. Thus, we have primitive and non-primitive data types in Java. So in primitive data types, we have what we call integer, we have what we call boolean, we have what we call double. That's primitive. Are you together? Primitive. We have what we call primitive data types. We have what we call integer. We have what we call boolean. Boolean is double or please. Then we have what we call double. Are we together? So, in what? In non-primitive, we have what we call string. Non-primitive data types, we have what we call string. Are we together? We have what we call arrays. Then we have what we call classes. Or sometimes it's called packages. So, here, what we are saying in primitive data types, if an integer is going to take a whole number of what? From 0 to what? 9. Inclusive 0, 1, 1, yes, or inclusive 1, 1, 1, 2, up to 1, 3. So anything, example, that what? That age. So in Boolean, it's going to take something like yes or no. It's going to take yes or no, true or false, 1 or 0. That's what Boolean takes. Rainy or not rainy, sunny or not sunny, that's what it takes. So in double, here it takes, though we have long, we have short, and whatsoever, here it can take something with decimal places, 1.1 or something, just with a what? With the decimal places within your number. So this is what we call as what? Primitive data types. So in a non-primitive data types, we have what we call a string. A string is, your name is a string. We have what we call name or names. When we talk of arrays, we have something like, normally an array is a given number of lists that are going to be kept within an element. And normally those arrays are going to be kept within a given list, and that list is referred to as element, and this element is what? It's being accessed by what we call an index number. Example, you are going to store 1, 3, 5, 4, 5, and whatsoever n. So these are the elements within an array. So this element within an array can be accessed by what we call what? By what we call index number. So usually the index number in an array starts with what? With index 0. So here is 0, here is 1, here is 2, here is 3, then it continues. So normally the number of index is identified or is being calculated by what? by the number of element minus 1. Are we together? If the total number of elements you have is 10, then your index number should what? Should be 9. That means because it's starting from what? From 0. I hope you are following this. So, and this is accessed by this. So our classes, as usual, are the what? The names usually, they have the blueprint to our programming, and it's going to be housed within a dictionary or an element also, which are accessed by their element. So looking at this, we said though primitive data types are what? Basic building blocks, while non-primitive data types are more complex and then structure in nature. So though this is Java, we are not going in depth into these primitive and non-primitive data types, but assuming we are working with a data structure, we are going to go like a little deeper into these primitive and non-primitive data types. So looking at, let's look at this example of a classes that we have been mentioning. We said they are blueprint of creating an object with a specific attribute, and that attribute can be what? Data, and then the method can be what? Can be a behavior. Example of this is what? Class, maybe a person. Are we together? If you remember, when we are writing our first program, we said class what? Hello world, right? The blueprint of that program is what? Hello world, and so on, and then so forth. So, looking at this, when we talk about integer, we have explained it here already, but this holds a value or stores a 1 byte of a whole numbers from what? From -128 up to what? -128 up to 127 of a what? Of a numbers. So in the integer, we have short integer, we have long integers. The short integers here stored a 2 byte, it is a 2 byte storage that stored a whole numbers from -32,768 -32,768 to what? +32,768. That's what it stored here in what? In a short byte. We have a long byte which stored from a 9 million or from a 9 million to a 9 million and so on. So we have also what we call float. We have double as we have given it there with what? With 15 decimal places. We have what we call car. We have what we call car. There is difference between car and a string. There is a difference between car and a string. When we set a string, it can give maybe to say this is double quote, please. Bamanga. Are we together? Something like this one. So that means if you are having what? If you are having a string here. But if we set a car, it can be what? Single quote, then B single quote, that. You get the difference now. This one is using a single character, this one is using a multiple character, housed within a double quote, this one housed within a single quotation. So Boolean, we have explained that one, yes, no, true, false, and the rest. So, and I believe our data types are well understood. So the next thing we are going to look at here is what? Is the basic operators in Java. Operators are used in our day-to-day mathematical operations, right? When we want to perform calculations in mathematics, we use operators. So the same thing here, with arithmetic operators, we have relational operators, we have logical operators, and we have bitwise operators. These are the 4 operators that we are going to concentrate on in this Java programming class. Looking at the arithmetic operations is our arithmetic operations. Our arithmetic operations are what? The plus sign, the multiplication sign, which we usually use what? We usually use asterisk, and then our division, which we usually use forward slash, then our minus sign, then our modular operations. Looking at this, under arithmetic operation is that this one, the function of this is just to sum up the two numbers or a given variable in Java programming. This is to multiply, assuming you are what? You're adding a variable my var1 or my var is equals to my var1 plus my var2. Here is maybe my var is equals to my var1 1 multiplied by my var2. That's it, the same thing here. The only thing is this modular. The modular here is assuming my var is equals to my var1 modular my var2. Here, assuming you have assigned, let's assume you set int my var1 is equals to 5. And again, you set int my var2 is equals to 2. Are we together? So, here if you come to this, you know it will be equals to 5 modular what? 2. In essence, what it's doing here is going to take 5 and divide it by 2, which usually going to be 2.5. But there is nothing to what? To be considered as with decimal place here. But what we are going to do here, in essence, is to look at the what? To look at the remainder. It means 2 can go into 4. How many? It can go into 5. How many times? This is what they want you to calculate. 2 can go into 5. How many times? It can go into 2. Then it will remain what? It will remain 1, right? It will remain 1. So here, the answer to this is going to be my var is equals to what? It will return the value of 1 here. As simple as this. This is what it will return when you use this. That's what? How you use your what? Arithmetic operation in this. So we are going to look at what? The relational operations. The relational operations relational or relations operations. Here in relations operations, we have equality sign. We have this double equality sign. We have not equals to. We have less than. We have greater than. We have less than or equals to. We have greater than or equals to. That's it. So this is used to compare a given variable, or it's used to compare a given identifiers. Now, in mathematical operations, if you want to work with, let's assume you want to compare two numbers. You said 2 is equals to 2. Isn't it? You are comparing. But in what? In Java programming in general, you use double equality sign to what? Use as equality sign. If you say, let's assume we just use a mere statement. If 5 is 5 equals to 5, let's use is 5 equals to this. It's not, right? So we use this to compare for what? For variable in this. So this is what? It's used for not. is used for not. Thus, 5 is not equals to what? 2. Isn't it? 5 is not equals to 2. This is used for comparing a less than or greater than. If assuming 5 is less than 2, there must be a statement, right? And what have you? Or 5 greater than this, there must be a statement, isn't it? So again, it's used to compare. Let's assume if 5 is less than or equals to 2. You see, this statement is definitely what? False, right? But if you look at this, assuming you say 5 is greater than or equals to 2, this statement is definitely correct. Then some statement will follow. So this is how you use your relational operations or operators. Are we together? So we also have what we call logical operators or logical operations or logical operators. We have logical operators or operations. So here in logical operators we have double ampersand. Hey, my ampersand is just like a dollar. Double ampersand, which denoted for and. We have not. We have O, which is a vertical bar as our O, we also have our node. So here, if you are comparing, if 5 is greater than 2 and 2 is less than 1, some statement will follow, isn't it? Or you're saying if 5 is greater than 2 or 2 is less than 1, some statement will now follow. Or you are saying if 5 is greater than 2, not less than, 1, some statement will follow. So that's how we will use these logical operations or logical operators. The last operators we have in the list is the bitwise operators. Is what? Is the bitwise operators. Bitwise operators. So here we are going to look at this and then this under bitwise operators. This is used for increment, and this is used for decrement. This for increment, this is for decrement. Let's assume you said you print something and you want to increment. You said h plus 1. So whenever it print h, it will go back and then start counting. So we use this in what? In count. Or whenever it what? There is a printout of 1 of h, it will now decrement h by 1 or by 2 or by any given numbers. That's how you use your bitwise operators. Are we together here? The next thing we are going to look at here is the what? Input-output operations in Java or IO operation in Java. Looking at the output in Java, output provides you, or Java operations in Java provides you with a scanner object for what? For input, and the system.out for what? Providing output. So in Java, you can easily use these very three keys in Java for outputting your variables or displaying something on the screen. We have what we call system.out, or let me adjust like this, system.out.print, Then you have, if this is what you're printing, semicolon. So you also have, this is just print. You also have system dot out dot print ln, the same thing. You also have system dot out dot print if. So these now, the explanation is these are, they all perform same thing, that's of displaying Bamanga on your screen while programming. But the difference here is that these are, this command or these very functions or Java functions print out what is inside this bracket and within the code, and it will display it on your screen, and your cursor will remain on the same line of this. While the difference here with this one that is having ln is that the Java programming will print what is within this code, and your cursor will go to the next line. While here it will now format what it will print here within this code, just the way it's formatting in C and C++ programming. That's just the difference, but they all perform one single function. The only thing for you is just to adopt one functions and then continue to use them consistently, as I mentioned at the beginning or during your naming conventions. Are we together? So you use this system.out.print for what? For printing out your what? Your variables or identifiers on the screen, or in Java programming languages for outputting variables. So for imputing variables, if you remember when we are saying something about input-output operation, we said Java programming provides you with a scanner object for imputing or for accepting data from the user, while the system.out.print for printing output from the user. Sorry. So looking at the different ways to get input from the user. So in order to use object of a scanner, we need to import this what we call Java util object. We need to update this Java util scanner. So at the beginning of your statement, you need to update or what? Import this very java.util.scanner dot what? The scanner package. This is a package that we worked or we import them within our programming code in order to be able to accept its data from what? From the user. So we are going to what? So that we need to create this object from the classes. So what we are going to do now, we are going to write a small program that can accept an integer value from what? From the user. So looking at this, at the beginning of our program, usually we start with a class. Let's assume we set class, let's say we can set input. Isn't it? This is the blueprint. Class input, right? So, but we need to import this, isn't it? Here we said import java dot util. This is not part of what we are doing, please. This is not part. So java dot util dot scanner, java dot util dot scanner is what we are importing. We end this statement here like this. So what we are going to do next, after we have started our program, we are going to declare our what? Main method using our public static void, there's a space here, void, isn't it? Main, public static void main. You have your string, then aux, isn't it? Then you still have your what? Your curly braces. Make sure that if you're closing these curly braces, you close them here. So this you import them. So it's now what you're going to do. You create an object. You create an input object or input scanner object by doing a scanner input. A scanner input is equals to what? New scanner. This is the name of the scan. This is the name of the scanner, and you're what? Making it as what? As new scanner with what? System. This is system.in. System.input. Then you enter your what? You enter your statement with a semicolon. So what we are going to do now, we want to accept something, but we don't want the system to be blind. That's why we said our program needs to be what? Pragmatic, right? So we are going to have a display on the screen. To display something on the screen, we can say system.out.print, isn't it? We adopt this. So what are we printing it out? So we said enter what? Integer number. So it means this very line will now what? Will now display a user to enter a what? An integer value. We might decide to put a semicolon like this and then leave a space if possible. Then we come back and do our kind of the initialization. Initialization here we can set we want to impute integer. Integer are usually number. We can set int number is equals to what? Then our variable. Our variable here is going to be what? Impute dot next integer next int. Then we still end this statement. This is our declaration now. We declare this number to hold anything that you are keying in into this very object. Are we together? This is what we are doing now. This is the int, this is the what? Is the variable, this is the data type, this is the value that it will contain. We are not specifying the value here. That's what we said, input.nextInt. So whatever you're keying in, there should be an integer, and it's what it's going to accept from that input and store it on what? On a number. Are we together? It will store it on a number. So this, it will provide a what? A text box for you to what? To write that very particular number with a heading called enter integer. So after you have entered integer, what will happen? I believe we need something like to display what has been accepted, right? So now you are going to use the same function of this called system.out.print, isn't it? So here you are going to say you entered, maybe you are not here. What you are going to do, you are not just going to leave it like this and then all right. So you are going to close this because this is a string, and so your string normally, if you remember, is going to be within a double quotation. So you are going to use a concatenation parameter, which is what? Plus sign. Plus sign is used to what? Concatenate what you have entered here with what? With the what? With the variable. What is the name of the variable? This is the name of the variable. That is number, right? That is what? Number. You now close that bracket, end your statement. Are we together? So with this is all. If you like, you can put impute. That's the name of this class. Impute.close. If you want, but it's not mandatory. But if you put it like this, it means you have ended this program. Now what's left for you is to close this bracket first. You close this bracket. Let's assume this bracket should be somewhere curly braces place. Then you close also this one. So that this program is done, please. You can copy this. We are going to do practical aspect of this very this thing on this very channel. So I believe this very text is quite well understood. You have input your scan or utility scanner package or utility scanner object. This package will allow you to what? To accept or to use what is going to accept or accept data from a user. That is why you are now importing this. You now open your class or declare your class. You declare your main method here. Then you now declare your what? Your scanner object, where you're scanning. The name of is just like a data type. The name of the input is a scanner, which is the package you have declared here, and the variable is input, and you are assigning whatever is imputed into the system as new scanner. System.out.print is the function that will display something on the screen. So it means at the end of the day, your output will be like enter integer, enter integer with this, and you will now key it in. Let's assume 8. Once you put 8 and hit enter, this function will be like, this will close again. It will be like you entered what? Assuming we have dot dot, you entered, what did you enter here? You entered what? 8, and that's all. This is what all this code is going to do for you in these particular exercises. So I believe this is also well understood. You are advised to go through these namings and things convention. Look at the rules, look at how you name your variables, how you name your identifiers, how you call them. Just remember that Java is a case sensitive. You should not be using your variable anyhow. Names with capital letter is different from name in small letters. And throughout these classes of Java, we believe you have learned the fundamentals of namings, naming conventions, data types, operators, input, output. This is what we have discussed, or this is what we have treated in this class, and we believe this is quite understood. Remember to what? Keep a consistent practice and exploring many ideas. Think deep, so that you can quite all right be a good programmer. Thank you for being with me in this session. In our next session, we are going to talk about the decision making in Java. Thank you.